On June 30th, 1908, a quiet morning in the Siberian wilderness was shattered by one of the most powerful natural explosions in recorded history. At around 7:17 a.m., witnesses across the Podkamenia Tunguska River region reported seeing a blazing object streaking across the sky. It glowed intensely, leaving behind a trail of white-blue fire so bright that some described it as a second sun. This fiery object sped toward the northern horizon before erupting in a massive explosion that lit up the sky and sent shock waves rolling across the Earth's surface. Although the explosion occurred in one of the most remote, uninhabited regions on the planet, the few people who lived or traveled there experienced a terrifying display of raw cosmic power. Eyewitnesses recalled that the sky appeared to split apart just moments before the blast. A heated wave washed through the air, followed by an ear-splitting boom that echoed across valleys and forests. The force of the shockwave knocked people off their feet, even from dozens of kilometers away. A reindeer herder named Seaman Semenov described being hurled backward by the blast as flames filled the horizon. Windows shattered, wooden buildings shook violently, and the ground itself seemed to tremble. Even hundreds of kilometers from the explosion, people reported hearing a loud series of booms, as though artillery fire or distant thunder was rolling across the landscape. Despite the immense power released that day, no confirmed human deaths were recorded, owing to the sparse population of the region. Once the dust settled, the full extent of the devastation became clear. Over an area of more than 2,000 square kilometers, approximately 80 million trees had been flattened in a radial pattern. The forest lay stretched out like fallen matchsticks, with trunks pointing outward from the point where the blast wave had struck. At the epicenter, investigators later found scorched, branchless trees still standing upright, their bark blackened by extreme heat. This eerie forest of telegraph poles became one of the most iconic visuals associated with the Tunguska event. Yet, curiously, there was no impact crater, nothing to suggest a meteorite had struck the Earth's surface with such catastrophic power. This lack of a crater baffled scientists for decades. Normally, an explosion large enough to flatten millions of trees would leave behind a massive hole in the ground. But at Tunguska, there was none. This strange detail ignited speculations ranging from underground gas releases to exotic phenomena like antimatter or mini black hole collisions. However, the explanation that gradually achieved the most consensus was far simpler. The object never reached the ground. According to modern scientific analysis, the Tunguska explosion was likely caused by a small asteroid or comet fragment entering Earth's atmosphere at tremendous speed. As it plunged through the air, friction created intense pressure and heat, causing the object to explode in an airburst several kilometers above the surface. This high-altitude detonation released energy equivalent to 10 to 15 megatons of TNT, roughly 1,000 times the power of the Hiroshima bomb. It took nearly 20 years for the first scientific investigation of the site to take place. In 1927, Russian mineralogist Leonid Kulik led an expedition into the remote Siberian taiga. He expected to find a crater filled with meteorite fragments. Instead, he discovered a flattened forest, but no obvious impact site. Kulik and his team collected soil samples and interviewed surviving witnesses, many of whom described the fiery descent of the object. The absence of large meteor fragments puzzled Kulik, but he did find microscopic particles embedded in the soil, tiny bits of silicate and metal that hinted at an extraterrestrial origin. These findings supported the idea that the object had disintegrated completely before striking the ground, leaving behind only microscopic traces. Although the Tunguska region is isolated, its effects were felt around the world. In the days following the explosion, people across Europe and Asia reported unusually bright night skies. Observers in London, for instance, claimed they could read newspapers outdoors at midnight without artificial light. Scientists now believe these effects were caused by fine dust particles thrown high into the atmosphere by the explosion. These particles reflected sunlight long after dusk, creating a phenomenon known as noctilucent skies. Atmospheric sensors as far away as England also detected unusual pressure waves, suggesting that the shock wave from Tunguska had circled the Earth multiple times. Despite the overwhelming evidence supporting the cosmic airburst hypothesis, Tunguska has never fully escaped its aura of mystery. The lack of immediately obvious meteorite remains left room for speculation, giving rise to unusual theories. Some suggested a massive volcanic eruption or a giant lightning storm, while others proposed an exploding comet made entirely of ice. A few fringe theories went even further, claiming the explosion was caused by a crashed alien spacecraft or a secret government experiment. While these ideas remain popular in books and documentaries, they have never gained acceptance within the scientific community. Modern research continues to reinforce the explanation of a cosmic object detonating in the atmosphere. In recent decades, computer modeling and satellite data have strengthened the scientific understanding of what happened in 1908. Researchers now believe the Tunguska object was likely a stony asteroid, roughly 50 to 60 meters in diameter. It entered Earth's atmosphere traveling at more than 20 kilometers per second and broke apart under extreme pressure. The explosion occurred at an altitude of about 5 to 10 kilometers, channeling its energy downward and creating the pattern of destruction seen on the ground. The event closely resembles the more recent 2013 Chelyabinsk meteor, which exploded high above a Russian city, injuring over 1,500 people, but producing no crater. Tunguska, however, was far more powerful, releasing about 30 times more energy than Chelyabinsk. Beyond the scientific implications, the Tunguska event also serves as a sobering reminder of the dangers posed by near-Earth objects. A slightly different trajectory or timing could have resulted in the explosion occurring over St. Petersburg, Moscow, or any other major population center, leading to catastrophic loss of life. Tunguska demonstrates that even relatively small asteroids can unleash destructive power on a massive scale. This realization has driven modern efforts by space agencies to track and monitor potentially hazardous objects that orbit near Earth. The hope is that one day, humanity will be able to detect and, if necessary, deflect such threats before they come too close. Although more than a century has passed since the Tunguska explosion, the event remains one of the most dramatic collisions between Earth and the cosmos in recorded history. It occupies a unique place in both scientific research and popular imagination. The image of millions of trees lying in perfect radial symmetry across the Siberian landscape still captivates researchers and enthusiasts alike. Tunguska represents both the fragility of life on Earth and the immense scale of the forces at play in our solar system. It stands as a powerful reminder that our planet, though seemingly stable, is part of a dynamic universe where extraordinary events can unfold in an instant. In the end, the Tunguska event is a blend of scientific fact, human testimony, and lingering mystery. While modern science has provided strong explanations for what happened that morning in 1908, a sense of wonder persists. The remoteness of the site, the delay in investigation, and the absence of a definitive crater all contribute to the event's legendary status. It remains one of the most fascinating natural phenomena ever recorded, a moment when the sky erupted, the earth trembled, and the quiet Siberian forest became the stage for a cosmic event unlike anything else in modern history.